so arc measurement, properties of chord. So we already did properties, can you see? We already did properties of tangents. So we have some more vocabulary. The first one is central angle. Central angle is an angle whose vertex is the center of the circle. So a central angle would be this guy here. All right, that is a central angle. So we can write angle APB. You guys will also eventually need calculators. Give them in a second to get this. All right, a minor arc is part of a circle that measures less than 180 degrees. So for a circle, there's how many degrees total in a full circle? 360. So 180 is going to be half of that, right? So a minor arc has to be less than 1/2 of the circle. So we name, this is important, we name a minor arc with 2 letters. So a minor arc could be the arc AB. When you guys are describing arcs, make sure that you are drawing your arc symbol. If you just write letter AB, I have no idea what that is. All right, a major arc is part of the circle that measures between 180 and 360. So it's not the full circle, but it's more than half, but less than the whole thing. So we name a major arc with 3 letters. We name a major arc with 3 letters. And so a major arc could be from A to C to B. So we can write arc ACB.
But would it wouldn't be ABC because it's only half.
Right. All right, a semicircle is basically half a circle. An arc with endpoints that are the endpoints of the diameter of a circle. The measure of a semicircle is 180 degrees. For a semicircle, we also name it with 3 letters. So a semicircle could be, like what Lulu just said, from A to B to C. And technically, this circle is a bad circle because it doesn't have a diameter. Technically, we need a diameter to determine whether it's a semicircle, but it is what it is. We just go with the flow here. All right, the measure of a minor arc. The measure of a minor arc is the measure of the arc's central angle. So let's look at this. Look at this angle here. Let's say that this angle was 50 degrees. And that means my arc is also 50 degrees. That is important. Whatever your central angle is, meaning the center of the angle, that is also your arc. So what we're going to write is the measure of arc AB is equal to the measure of angle APB. So all that says is that that arc is the same as that angle. You with me, Michael? Okay. So the measure of a major arc is the difference between 360 and the measure of the related arc. We just kind of need to add, let's see here. we will subtract the arcs from 360. I think that's the easier way than doing it how they want us to do it. We'll see in a second. That's good?
For semicircle, when you like name it, do we put the thing above?
Yes, you still have the arc. So your semicircle here, the arc ABC. Write that down. I forgot to add that. Alright, so example 1, finding measures of each arc of circle R. It tells us that MP, bless you, is the diameter. Alright, so I'm going to highlight that. That's important to me. MP is my diameter. So I know that on each side of the diameter it's going to be 180 degrees. Right? The diameter is basically, think of it as a pizza. Just splits it in half. So that means this part over here, NRP, is going to be 180 degrees. That's the top part of my circle. The bottom part of my circle should also be 180. They already gave me 100 degrees. What's this little piece going to be here? Nope, not 100. It has to add up to give me 180. So that would be 80. Does that make sense, guys? We're just kind of splitting it up. It is probably good practice for you when you know what your central angle is. I like to write it also on my arc because sometimes it gets a little crazy trying to figure out which arc is what. You don't have to do it that way, but it helps. All right, so the measure of MN. Is MN or arc MN going to be a minor or a major arc? Minor, how do you know? You guess? Because it looks small, right? But also there's how many letters here? 2. If it's a minor arc, it always has 2 letters. So, Izzy, arc MN is equal to what? 100 degrees. Good. All right, the measure of MPN. So I'm going to start at M, I go to P, and I go over to N. So from M to P is 80 degrees. From P to N is 180. So what'd you get, Michael? 260. 260, good. What Michael did was he just added them up. Start with your finger here and go all the way around until you hit each letter. It would not be the same if you went this way, M, N, P. Not the same thing. All right, what about R, P, M, N? 180 because it is 80 degrees plus 100 degrees. So this is basically the semicircle. Measure PMN. What about the measure of PM? 80 degrees. Do we understand the arcs? The measure of the arcs? Yes, no? Head nod? All right. Okay, so then we have the arc addition postulate. This says the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. Alright, so that's pretty long. What I want you to do is I want you to draw a circle. Try to get it as round as you can. Don't make it a diamond. We're going to put 3 dots on it. Doesn't matter where your dots are, Just label them A, B, and C. Okay, so here's what we would do. If I wanted to find the measure of arc AC, meaning this whole thing right here, what I would do is I would add the measure of arc AB, which is this first part. I would add this guy. What else would I add? BC. I will also add the measure of arc BC. I do not expect you to remember this postulate at all. All you have to know is that if they gave you a number, say they gave you the number 5, and said what are ways to make 5? You could do 1 plus 4 or 2 plus 3. It's the same exact concept. We're adding what we have to equal the whole thing. So, what I like to do with circles is I like to fill out my circle before I even answer my questions. It's just easier that way. A full circle is how many degrees? 360? Alright, they gave me 3 angles so far. How do I find the 4th angle? Guys? Add them and do what? So you can add them all up and subtract from 360, or you could do 360 minus 80 minus 110 minus 40. What are you left with? Let's add, we're going to subtract all those angles from 360. Michael, practice this, put that away. You get 130? Good. Write that in there. That's 130 degrees. So now I know whatever my angles are, my arcs are the same exact thing. Because it is going to equal 360. Alright, so now we can fill this out. What is the measure of arc GE? And which way do we look? Do we look at GE from the left or GE from the right? This is important. Huh? Well, okay. GE with 2 letters has to be what? Minor or major? Minor. So if I go to the left, you see how that's more than half the circle? So that would be a major arc. So I need to go from the right, G to H to E essentially, but we're just doing GE. So I have 40 plus what? 110. So what is the measure of GE? 150 degrees. Don't forget your degrees. All right, Ashley, the measure of arc GEF would be what? What do I add together for GEF? Okay, what else? 110. Okay. And what do we get? She stopped once she got to F. We get 230. Alright, I am completely okay with adding up what you have. I am also okay with you guys seeing for GEF, I'm doing all of this, right? If you see that I could subtract 360 and 130, you still get 230. Like if you want to subtract the piece that we're not using, that's perfectly fine too. You can do it either way. I typically like to add them up, I'm just used to that. You can do either way. Lulu, arc GF is what?
130.
Good. Kenzie, arc FHE is what? So we're going from F all the way over to H and then back over to E. So we're going to add 130 plus what? 40 plus 110. Right, add all those up. What do you get for FHE? What'd you get? 280. Good. All right, any questions here on how to measure the arcs based on our angles? All right, one more page of notes. Turn the page to page 6. We have more vocab. All right, congruent circles. Congruent circles are two circles that have the same radius. So I'm going to make a circle, point, just center. Is a radius a line that goes to the full circle or half the circle? Half the circle, good. So let's say I had a radius here and a radius here. They don't look the exact same, but I know they are if they both have the same measurement. So if I measure each radius is 5, those are congruent circles. All right, congruent arcs. Two arcs that have the same measure. So let's draw the center. I'm going to make a little angle here. All right, so let's say, this is 60 degrees, my angle. If my central angle is 60 degrees, what's my arc? 60 degrees, they're the same. Those would be congruent arcs. Ignore those other two circles. I'm not going to talk about that right now. All right, we have 3 rules. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So, a chord means it touches both sides of the circle but doesn't go through the middle. Right? So let's draw congruency symbols here. AB and BC are my chords. So we're going to say this segment AB is congruent to segment BC. Then arc AB is congruent to arc BC. So what that means is that if we have 2 chords that are congruent, this arc and this arc are also congruent. So if one is 20, the other is 20. All right, your second rule, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. All right, so perpendicular means that this chord and this diameter will create a right angle. So that means that if that happens, that chord bisects each other. So we can write this segment DE is congruent to segment EF, then arc BG is congruent to arc GF. right, your last rule says, in the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. All right, so these chords are congruent, and if they are, those two little smaller lines will also be congruent. That's all you have to write down for that. All right, so let's see some examples. Example 4a says, find the measure of arc AD. All right, well, they told us that these chords are congruent. So what does that mean for these arcs? Yeah, they're going to be congruent too, so they're equal. How do I set this up as an equation to solve for x?
2x equals x plus 2.
All right, do not use Desmos for this. Let's just work it out by hand. Keep our brains fresh. How do I solve for x?
Minus 2. Oh, no, minus 1.
Yeah, subtract x. So 2x minus 1x is just 1x, which is equal to 40. So x is equal to 40. They did not ask me for x. They asked me for the measure of arc AD.
80.
So how'd you get 80?
40 plus 2.
All right, so Lulu says it was the arc of AD was x plus 40. So she plugged in the 40 that we solved for. And our answer here is 80 degrees. That is the measure of the arc. All right, in the second example, it says in the diagram of circle C, QR is equal to ST. So here's QR, that's equal to ST. They're equal to 16. They already told us that each side there is 16. So because those two sides, those chords are congruent, that means that these chords are also congruent. So if I want to solve for x, I'm going to take 2x and make it equal to 5x minus 9. All right, so 2x equals 5x minus 9. If I want to solve for x here, I subtract 5x from both sides. That cancels out. 2x minus 5x is negative 3x, which is equal to negative 9. I divide by negative 3. X is equal to positive 3. They didn't ask me for x, though. They asked me to find CU. What is CU labeled? 2x. But instead of x, I'm plugging in 3. So what is the measure of CU? Do you guys understand what we just did? Okay, so you are going to work on the practice. So before we start the practice, let's look at number 9, 10, and 11. We're going to talk about common and internal, external tangents. So when it comes to tangents, we're looking for whether it is a line that's going either, if it's just on the circle, or if it's going between or outside the circle. What does internal mean? Inside or outside? Inside. So external is outside. So if you look at these tangents here, are they inside or outside of the circle? Outside. So this would be what? This would be external. What about number 10? You guys agree? This is internal because the tangent is in between both circles. And so for 11, we have two two tangents. Are they internal or external?
Internal.
They're internal. All right, so you guys are working on all of page 7. This is a review of day 1. Turn the page and you have all of page 8. I know it looks like a lot, but it really isn't. I also want you guys to, on page 8, cross out, oh, I didn't put it on here, cross out 22, 23, and 24. You're not doing 22, 23, or 24. All right, so you have 20 minutes. At 11 o'clock, we are going to go over these. Actually, you have 15 minutes. So 10:55, we'll go over the answers. Okay, meaning I'll put the answers up here. And you should probably start on page 8 because you weren't here for the first part. So you may know some of the vocab, but until you listen to day 1, you may have some trouble with it. So start with page 8. All right, you guys ready? All right, so what'd you get for number 1? Good, because that's just segment AB, so you should get B, that's the 4. What about for number 2, point H? What'd you get? E. Good. Guys, I'm going through these quickly, so just yell them out. Number 3? F. Number 4? CH. D, radius. Number 5, C.
A.
A, that's the center. Number 6, HB.
C.
C, which is diameter. Number 7, line AB.
G.
No, not G. H, if it goes through, if it was a tangent, it will only touch the circle. So that is H, the secant. And so DE, see the difference between DE and AB? Lulu? It just touches the circle, it doesn't go through it. So DE would be your common internal tangent. All right, we already did 9 through 11. So 12, 13, and 14, this is from our homework on day 1. We're going to prove that AB is a tangent. So here's your right angle. Your right angle is always between the radius and the tangent. All right, for number 12, did you guys realize that you had to add 5 and 8 together to get 13? All right, so you should have 5 squared plus 12 squared equals 13 squared. You get 169 equals 169, so your answer is yes. Angela, you get this? Okay. Number 13, you guys get yes or no? No? So 5 squared plus 15 squared equals to 17 squared. You would have gotten 250, which was equal to 289. So the answer is no. For number 14, before I can even solve this, I only have one part, which is the radius. If I want to use the whole triangle for the diameter, I need to add that 10 up there. So you could have had A squared, which could have been 20 squared, plus B squared would have been 21 squared, which was equal to C squared, which is 29 squared. In your calculator, you would have got 841 equal to 841, which would have been yes. Any questions on 12 through 14? All right. 15, 16, and 17. They're both tangents with a common external point, so they are congruent. Did anyone get an X for this, an X value?
Yes.
What do you should get a 2.5. All right, for number 16, you should have had X squared plus 25, which is equal to 50. What did you get for your answer?
Positive negative 5.
Good, plus or minus 5. If you want to write this twice, put negative 5 and positive 5. That is perfectly fine. They are both the same answer. If you like the plus or minus, that works too. For 17, I have 3x squared, which is equal to 12. So x equals what? What'd you get? I got plus or minus negative 2. Or plus or minus 2. Actually, double check your work on that one. Sounds like you probably just messed up on setting it up. All right, number 18. I can call this A, this B, and that's C. So we can have r squared plus 28 squared, which equals r plus 14 squared. When you use Desmos, we don't use r's. We type in x squared plus 28 squared equals x plus 14. So for your answer, I got 21. You guys get that? All right, if you're all good on day 1 practice, turn to day 2 practice. Determine whether the minor arc or the arc is minor, major, or a semicircle. I'm going to go through these. Number 1 was minor. Number 2 was semi. Number 3 was a semicircle. Number 4 was major. Number 5 was minor. Number 6 was minor. Number 7 was semi. And number 8 was minor. Even if you didn't get this far, you can still copy it down so you can go back and practice and check it later. Nine through 18. For number 9, I got 70 degrees. Number 10, I got 180. Number 11, I got 180. Number 12, I got 210. Number 13, I got 70. Number 14, I got 110. Number 15, I got 290. 16, I got 30. 17 was 280. And 18 was 290. You may have to check some of these answers. I did them very quickly. But to fill out your circle, if this is my diameter, it said MQ and NR are diameters. So if we look at the first diameter here, we choose a different color. So look at the green diameter to the left. They told me that this was 70, this piece was 30. So I'm missing how many degrees? 70 plus 30 is 100. So I'm only missing 80 degrees, so that's what goes there. It gets tricky because of that arrow. And on the other side, this is congruent to that one. So this would be 70, and this would be 110. All right, 19 through 21. 19, I got 130. 20, I got 165. And 21, I got 60. On 21, I know a full circle is 360. So I did 360 minus 140 minus 110, which are these two arcs, and I was left with 120. They gave me these little arcs right here, so that told me that they're both congruent. So I did 120 divided by 2, and that gave me 60. So each of these pieces were 60 degrees. We skipped 22 through 24. And then we had 25 through 27. All right, we have a little bit of time. For DC, what would that be? 8. Because if this is 4, that's 4. The whole thing is 8. What about AD? 8. This is also 8. They told you that BC was 8. They're congruent. What about EC?
12.
Okay, so for EC, this radius is 6. So I know this radius is 6 and this radius is 6. So they asked for EC, it is 12. Alright, even if you didn't get a chance to work on them, at least I hope you wrote down the answer so you can go back and check. Your homework is homework number 2. It's just one page, you guys can do it. We'll go over homework 2 before this class, then we'll take our mini quiz. Make sure you guys prepare for the mini quiz. All right, good job.